and then the ground is I could just connect it to the ground. So that's the ground. So let's now proceed on the code, and we can now do some useful application here. In this video, I'm going to show you how we can use this HC-SR04 ultrasonic sensor with an Arduino board. We will have a buzzer as well to indicate some trigger signals when a certain distance is achieved. Let's now work on some connections. There are 4 pins in this ultrasonic module. You have VCC, trigger, echo, and ground. VCC will be connected to 5 volts. Ground will be on ground on the Arduino board. Here, the 5 volts and then the ground. And then for the trigger and echo, we will use 2 digital pins on the Arduino, which we will use pin 2 and pin 3. So let's do some connections. I will not use any breadboard in this video, so just watch what I will do. First is I will bend this VCC and ground pin. So I will bend this like that, and then this one as well. There you go. So we have now the ground and the VCC already bent. So what I will do now is I will hook this trigger and echo pin directly on the header of the Arduino. Next would be trying to figure out where here in this header where's the 5 volts and the ground, because this is a programming pin. There's a 5 volts and ground there. We can use a jumper wire from here to there so that we can have a connection. If you're watching my channel for quite a while now, you will know that I'm not a fan of DuPont jumper wires. I actually use this kind of thin wires, which is the wire wrapping wire, for connecting modules to my Arduino. So instead of using this pin, what I will do is I will solder here on the VCC and ground, and then I will solder here. So I will check where is the ground and the 5 volts in these pins. Now I'm done wiring, and I found out by using the multimeter that this is the 5 volts and this is the ground. So these 5 volts, this wire, I soldered it here on VCC, and on the ground, I solder it in this ground pin. So now you know, I now have a good connection with the ultrasonic sensor. By the way, as I told earlier, you can still use this using DuPont wires, but I don't like the mess of DuPont wires here. So I just use this wire wrapping wire. So let's now connect the buzzer. Now I'm done connecting the buzzer. So I connect the buzzer on pin 4. This is pin 4 because there, if you look at here, that's 0, 1, 2, 3, 4. That's the fifth pin. So I connected that here, the positive. And then the ground is I could just connect it to the ground. So that's the ground. So let's now proceed on the code, and we can now do some useful application here. This is the source code of our ultrasonic distance measuring project. So as you see here, we define the trigger pin, which is pin 2, the echo pin, which is pin 3, and then the ultrasonic divisor, which is based on the speed of sound. We will use this later. So these are the macro definitions that we needed, and then here we set the serial monitor so that we can check the actual distance measured by our device, and then we have here the initialization of the pins. So the trigger will be an output, and then the echo will be an input. This one is an initialization of the trigger pin, so we set it first at low. That's the setup, and now let's proceed on the void loop. So in the void loop, we will define 2 variables, the duration and the distance. The duration will be the result of the function pulse in that measures the return of the signal to the echo pin. So what we do now is, and then the distance is the variable that holds the actual distance. what we do now is we trigger the trigger pin. So we put it on a high. There will be 5 volts on the trigger pin. Then we wait for a few microseconds. And then we set it to low again. This delay can be changed like higher value, but I just put 11 microseconds there. And then we can now start to measure the distance based on the result of the pulse in. So this is the ultrasonic divisor. This is based on the speed of sound, and now we can serial print the distance on the serial monitor. Then we add a 2-second delay. So now let's check the serial. Okay, as you see now, we have data coming in. It's 23.39 because it's actually measuring beyond my ruler. So let's put some abstraction here. Let's put it here on 4 centimeters. As you see, we're reading around 3.8. So there's some kind of tolerance here, and yeah, the value somehow changing, so that needs some kind of filtering. Now let's move this to around 8. This is 8, so we're getting 7.58, 7.6, 7.6. So maybe my ruler is not placed properly, but yeah, the device is working. Let's add now the buzzer. So we add here a new definition for the buzzer pin, which is soldered on pin 4, and then we initialize it here, pin mode, buzzer, then we set that to output. Okay, and then we can now have a condition here using an if statement. If distance is greater than 5, then buzzer, digital write buzzer is high, else it will be low. Digital write low. Buzzer low. Okay, so let's upload that and let's see if it will buzz. Okay, uploading. Let's check the serial monitor. Okay, the distance is 4. The distance is 4. As you see, it's on the sensor is actually on based on our ruler, it's on 4 centimeters. So yeah, it's changing. So let's move this and let's see if the buzzer will turn on. There you go. It goes beyond 5, and then we go back again. Then it become less than 5. If it go beyond 5, it will buzz. Closer, buzzer is off. Beyond 5, it will buzz. Closer, it will become off. So that's a basic example of our ultrasonic sensor interfacing to Arduino. We can make more projects using this ultrasonic sensor, and if you find this video useful, please don't forget to like and subscribe on my channel. Thank you.